Hello and welcome to the Tunze YouTube channel. So if you don't have TikTok for brains and you want to learn about pumps, we're here to teach you everything you would need to know in choosing a flow pump. So here you can see the full range of Tunze pumps, but this isn't only about Tunze pumps. We will discuss just the basics of what you need to know, whether you should choose an AC pump, a DC pump, what sort of flow rate you might need, how different manufacturers make their pumps so that the flow patterns can vary, and you need to keep this in mind when you choose a pump, profiles of pumps, so how they'll fit into your aquarium, how much real estate they'll take up, and all the factors to consider will be covered up next. So why do I need a circulation pump in my aquarium? Well, if you've ever walked around and you see a pond or a river that's dried up and there's just a stagnant body of water, you always see certain key things. It's full of algae. There's not much happening in terms of life. The water tends to get a low oxygen level and it tends to become very polluted. The flow in an aquarium carries the nutrients away to the filter system. It distributes the nutrients to the corals and the animals or the plants in the aquarium. Additionally, the flow circulates oxygen and keeps the gas exchange high so that the CO2 is degassed, new oxygen is brought into the water, and all of those processes help stabilize the pH of the aquarium. So circulation is fundamental to a healthy aquarium. What exactly does a circulation pump do? Well, you have a pump in the aquarium rather than a closed loop or older ways of doing this because it's the most energy efficient. The electricity is being used directly in the aquarium to move the water, and this is more efficient than, say, your return pump. In the past, people would try to put huge return pumps on filters. This not only reduces the effectiveness of the filter because the water is passing through too quickly, it causes problems for devices in the filter compartment to work properly because we have so much turbulence and so much flow that sensors and different systems can't function properly. So by having the flow in the aquarium, we get the most efficiency and everything works better. So is a circulation pump important for freshwater tanks or just saltwater? As far as freshwater goes, we're generally dealing with less flow, but this varies on the habitat and what we're trying to do. If I was trying to set up a habitat for African Rift Valley cichlids, for example, Malawi, Tanganyika, Victoria, those are huge lakes that have tides, they have currents much like the ocean. Larger flow pumps like we might use in a reef tank would be perfectly suitable. They also tend to help diminish aggression. If I was doing something from a calm lake or a little oxbow tributary, like say discus, angelfish, a lot of South American fish, these tend to be bodies of water that have very low flow. The water is moving, but it's more like a spring-fed stream. It's a very gentle flow. Water might be upwelling from the ground. So in these habitats, a lot of times your filter is enough flow. Maybe you'd want a small power head. And then there's very specialized things, like we might try to keep fish from different plecostomus, cories, catfish that come from strong rivers. There's also a large group of rheophilic cichlids. These fish need very high flow, and in some cases it might even exceed what we have in a reef tank because they'd be like whitewater rivers. It all depends on the habitat, and the same applies for a reef tank. We might be doing soft corals or zoos or zoanthids, polyps. These animals generally have less flow because they're sheltered within rocks or within coral formations. But an SPS coral that's right up towards the water's surface where there's extreme waves, different table acros, and the flow rates can be quite high. So everything's going to depend to some extent on what you plan to keep. Can I just use the filter's flow instead? Well, in some cases this might work. As mentioned, if you were doing a very basic freshwater community tank, normally if you're going to do this, you need to go at least one size over on the filter, but it is possible. Different South American and Southeast Asian habitats don't necessarily have very strong flow. They're small oxbow tributaries, just lakes where trees have fallen and water's kind of dammed up somewhere. And these fish, the flow is not particularly high, but there is flow. There was a school of thought more so in the 90s and the 2000s where we didn't really have the best power heads early on, where people would try to do these closed loops. They would try to pump a lot of the water through their filter. Not only is this extremely inefficient because now you've got to add head pressure to this, so you need a lot more electricity because you've got to pump up. The other problem is that when you get such a high turnover rate through a filter, a lot of times your ATO system can't function properly. The water's passing by your skimmer so quickly that it's relatively inefficient. Filter socks or any sort of mechanical media, you're practically pounding detritus into a solution in the tank. So having a low flow rate through the filter is generally going to result in more efficient filtration and a lot of energy savings. We had that video with Jaime from Aquarium Company. You know, he had that beautiful setup of all those native fish from Texas, and that's a fairly typical, you know, whether it's Asia, South America, Africa, these fish that live in these rivers, they have a fairly strong flow. It's a very broad spread flow. And he used that 6105 in there, cranked up all the way. That would be a pretty good example of a habitat as long as your plants aren't blowing away and where the fish, even in a freshwater system, are getting the flow they need. How many circulation pumps do I need for my tank? If this is a reef tank, I would say you always want to have 2 as a bare minimum. The reason for this is to alternate the direction of the flow is extremely useful. You can actually find examples of aquariums where a hobbyist didn't alternate the direction of the flow. And a lot of times you get a look over time. Now, this doesn't happen immediately, but you go forward 2-3 years, sure, everything lives. But it looks very much like the trees you might find at a coastline. They're all windswept in one direction, where the flow just forced every SPS coral to grow in one prevailing direction. It can look interesting, but you'll get better growth forms and a more open structure if the flow can change. The other thing is redundancy. Even though very good pumps, the manufacturers may have long warranties, that doesn't do you a lot of good when a pump breaks on a Friday or a Saturday and you're going to have to send it in or you're going to have to wait for a spare part. You need to have some sort of backup plan. I would always have 2 pumps so that I at least have one that works. You know, most of us start off and we start with a piece of equipment that maybe isn't the best, but it's what we could afford, or when we were dabbling in something, we thought, well, I'll buy this because it's affordable. But you eventually progress and you want better equipment. Keep the old pumps you had as an emergency backup. You always want to have backups for something critical on your aquarium. That, you know, just being honest, it is your responsibility to have these backups, not a manufacturer's responsibility to respond to your emergency. So positioning is probably one of the key things. You know, as far as where you should position your pump in an aquarium, I get a lot of people ask me, well, I tried this pump, it's way too strong, my sand's blowing everywhere. It's probably not the pump. Unless you did something crazy and went way oversized, it probably is positioning and placement. So gas exchange being one of the more important issues, you want to position those pumps so that they're towards the surface, or let's say the top half of the water column, and aimed very slightly upwards so that we get a good circulation of the surface and we get good gas exchange. We want to position the pump so that we get a sort of circular current that transports the water all the way around the tank, preferably the longest distance towards your filter, so that we sweep up all the detritus as it rolls around to your overflow or your filter system. Those would probably be the primary things to keep in mind. Most pumps, if they're well designed, you can aim them to some degree. And if you can aim it, then you can accommodate, here I'm blowing the sand, so maybe angle the pump up slightly. You also want to be mindful that if you angle the pump up too strongly, you could be creating a lot of splash that can be actually, in the case of a reef tank or any saltwater aquarium, somewhat destructive to your household and the equipment around the tank, to have a lot of water splash, because then you get a lot of salt in the air, a lot of mist. So that's something else to be mindful of. But a gentle movement of the surface is definitely a big advantage. You know, one thing that I would look for in a pump is definitely this ability to position it. A pump that is fairly static or can only pivot 1 or 2 directions. Ideally, a pump that you can angle in multiple directions tends to be more versatile. There are pumps that are definitely very useful or very specialized that just go one way, and those have their place, but as a general rule, the more you can position and aim a pump in a sort of a ball pump in a C-clamp mount, that does tend to be the most effective for being able to adjust for the circumstances in your tank. Can a circulation pump hurt my fish or shrimp? So this actually comes up quite a bit. It comes up especially with beginners. It's a complicated answer. I would say the answer is yes and no. Typically, if you find a fish sucked onto a filter or a power head, it was dying anyway. A strong, healthy fish can definitely avoid a flow source. Now, that's not universal. We definitely have fish that have a lot of surface area and aren't strong swimmers. They come from very still bodies of water or a very specialized habitat. The other thing that we would consider is that, as far as shrimp and crustaceans, this is an interesting one because, a lot of new hobbyists don't realize that shrimp and crabs molt. And a lot of times they think that their shrimp or crab was killed by their powerhead, and all it is the empty molted shell. It would be unusual for a shrimp or crab. It is practical to look for pumps with protection on them, that they have some sort of shielding, that the animal can't get sucked right into the propeller or the blades of the pump. And one thing you need to keep in mind is that a lot of times you will be stopping the pumps to feed the fish or to work in the tank. And during those times, animals can get in, and then when the pump does start back up, that can be a problem. When you get into DC pumps, you can have features where the pump pulses or runs at a very slow speed continuously, where it isn't actually making any flow, but at least prevents an animal from getting in. Anemones are probably the most vulnerable to pumps. What I've learned in my time as a hobbyist is that this comes down to a lot of skill. I actually was taught by a fellow hobbyist, Joe Ong, a really ingenious way to acclimate anemones, and that's that you take more or less a cheap plastic basket and you float it in the aquarium with your new anemone for about a week. That acclimates them to the water and the light. That's a primary phase that the anemone goes through, where it's constantly filling and emptying with water to adjust to the water chemistry of the water it's now in versus what it was in. And then you position the anemone with the pumps off. You leave the pumps off for a considerable time. You may put some baskets or something around the pumps or run them at a very low speed for a week or so. And then once you see that the anemone is static and not moving around the tank, you can proceed with returning your flow to normal. And usually everything's good to go. But that you do have to do some study on the type of anemone you have and what their habits are. How do I know if the flow is too strong or too weak for my aquarium? There's some technical reasons that's actually kind of difficult to answer. Manufacturers, for one, they can say what their flow rate is on the box. It may not necessarily be accurate. The other thing is a flow from a narrow outlet is definitely going to have much more force and velocity than a flow from a wider outlet. So if I had a pump with 2,000 gallons an hour coming out of an inch outlet, that's going to be almost like a fire hose. If I had the same flow coming from a 3-inch outlet, it's going to be a very gentle diffuse flow. So there's a lot of things to consider. And you also have to consider the animals you keep. A lot of animals come already from very high flow situations, and they've evolved for that, and that's what they're going to need to not get sick or to not lose tissue. But you have animals that come from very low flow situations, and if the flow is very forceful, they may never open. And when you get into DC powerheads, that's something else to consider, is that nature has very rhythmic natural cycles. You have tides, you have waves, you have storms, but overall it's a repeating cycle. And the animals adapt to the flow comes this way at this time of day and has this strength, and this is the time I feed. And so you don't want to buy something that it becomes a toy and it's just a wonderland for my amusement of, oh, I'd like to see the pumps do this and have flow going everywhere, when the animal is trying to feed and you have this totally chaotic flow. There's a lot of factors to consider in that, but we used to have targets of, say, 20 to 50 gallons per hour. This doesn't mean a whole lot. If you can get the flow really wide, you could do 100 times the tank turnover per hour. I understand that may not make the answer the easiest, but there's a lot of things to consider. I think for the average person that's just starting out, Say you're keeping zoanthids, mushrooms, some simple soft corals, then I would probably target, if my tank is 20 gallons, something in the neighborhood of 400 to 600 gallons an hour would be about right. If I wanted to keep it as simple and inexpensive as possible, I would probably choose a power head that has a modestly sized outlet where I had some force, where there was some energy that could distribute debris. So say, for example, I could take two of these 6045s or something comparable to this. And this is a nice one because I can mechanically adjust the flow. So even though it's not a full-on DC pump, I can adjust it from 450 to about 1200 gallons an hour. So with this, I can get the flow rate I need. I have some range of adjustment. If I had two of these, I could alternate them at very long intervals on a timer. And this would be a very good setup for a starter reef tank in the, let's say, 2 is probably a bit much for a 20, but if I had something in the 30 to 65 gallon range. And this would be perfectly suitable for mushrooms, zoanthids, something like a Blue Ridge coral, most of your polyps, star polyps and that, things that beginners usually start with, leather corals, and that you should have a good result with this. If I wanted to get into a smaller tank, the 6020, this is a unique low profile tank that addresses the need to hide the pump because I can put this low in the tank behind the rockwork, aim the flow up and out. It sort of has a periscope shape. And with this, I can project the flow out into the reef, and the flow rate is on the lower side. It's about 400 gallons an hour. And these would lend themselves, well, you could probably do one in a 20-gallon tank, and with the additional flow of your filter and that, you'd have plenty. Probably even up into a 30, one would do the job. You know, I wouldn't generally recommend having only one pump. When you get into small tanks, it can be difficult to have more. Then if we did something like this 6075 here, this is a much wider flow. This is what I was talking about, where you have this outlet that's 3 inches in diameter. You've got such a wide flow area that the flow itself is very gentle. It doesn't have a lot of force. You could easily put 2 of those in the same 65-gallon tank, and you would have a very strong water movement. You would be approaching a tank that size. That's 4,000 plus gallons per hour. So you're nearing, you know, what, 70, 80 times turnover, but you'd be able to do it without an issue, and you could keep all kinds of LPS and SPS corals, and you have the redundancy. You can change the direction the flow's coming from, so you could, you know, really get to your 30, 40 time an hour turnover rate, but you're switching which side the flow comes from. Only one's running at a time. So at least in a reef tank, in the end, you'll always see by the corals. If a coral's being blasted or doesn't like the settings you made or the positioning of the pump, the coral's not going to open and respond well. Leathers in particular, if the flow rate's not high enough, they'll develop a waxy film that they can't shed. Looking at the animals is the best demonstration of health. If a coral's really healthy, the polyps deploy, they're out feeding, you know, maybe not continuously, but they go through their normal cycles of deploying to feed, closing up. If they're always closed, you've got to consider flow to be one of the strong possibilities of why that might be. Do circulation pumps use a lot of electricity? They certainly can. You know, that's one of those things that largely comes down to the quality of the pump. So if we back up here, you kind of have a choice as a pump engineer. You can make your tolerances fairly tight. You can make everything very precise and well designed, and then they're very energy efficient. One compromise of this, though, can be that the pump needs a little more maintenance because everything does fit tight and you have to take good care of it. Another approach could be, I have a lot of variation in my machining. You know, these pumps can be made at a low price, but they're going to be noisy because there's a lot of play and a lot of slop. And then on the other side, they probably don't need as much maintenance. And that's just because there's a lot more room for calcium and things to build up without jamming up the pump. I would say that, you know, you want to choose a pump that's more energy efficient and just do the cleaning, because an energy efficient pump isn't going to heat the water as much. It's going to generally last longer because you're not drawing so much power. The power heats up the motor, and heat tends to provide more wear. It depends on the quality of the pump you purchase. You can find pumps that can do 3,400 gallons an hour with a very minimal amount of power, like the 6105 can do it with 11 watts. You can easily find pumps that pump that same volume of water and would use 80 watts plus. So they're all over the map, but it's usually a trade-off as an engineer between I want everything to be very precise and tight fitting and that everything works and that way it's quiet and energy efficient, or I can leave a lot of play and slop and then I can make it cheaper because I don't have to be so precise, and calcium and buildup won't lock it up so fast. Plus the motor will always have a lot more torque and can overcome resistance. It's really two schools of thought, but the consequence of adding less heat to the tank and just having a quieter, better built pump, to me, I would choose the more energy efficient. You actually can look at a lot of pumps on the shelf and see that they're almost all the same pump because they are the same pump. There's one producer, usually in China, and they're just producing it, and other companies are putting their name on it. And those pumps tend to be, you're dealing with a company that, well, we make pumps, but you can make pumps to run a bird bath. You can make pumps to run a pond or to empty a flood in a basement. It's not necessarily making an aquarium pump. You can specialize in something and make it really for that niche. Tunze, who I work for, with these pumps, we build them ourselves in Germany, and everything from the coil winding to the design, the molding of the plastic parts, all the electronics are designed in-house, and we source our cables and everything from Germany, and that's why we really know how to build a pump for aquariums. It's what we've done for over 60 years. So what is the difference between an AC pump and a DC pump? AC pumps simply plug into the wall. You have a US, or in our case in the United States, you have a US wall outlet, just as a standard plug. Here you have an example of an AC pump. In this case, it's a German pump, so we have a standard Schuko plug. This is just a plug in the wall plug. You plug this pump in, it's on and it runs. You can't control it. You can connect it to a timer, but it needs a fairly long on and off interval. You don't want to use it on a wave maker. Wave makers can be very destructive to propeller pumps because of the rapid on and off cycling. When you buy such a pump, you're more or less committing to, I just need a pump that runs continuously, or I turn it off a few times a day, or maybe every hour I switch between two pumps. But there are no fancy programs or anything more advanced that's possible. These pumps tend to be very durable. They tend to be inexpensive, reliable, simple. There's no electronics. There's very little that can fail. So that's something in there as a plus. On the downside, though, you just don't have that degree of control. If the pump's too strong, there's very little you can do to adjust it. So then we go to DC pumps. This is the twin, the 6040, which is a DC pump. And you can see it's considerably different. We have a lot more equipment. While the part that's in the water looks very similar, we have a controller. And with this controller, I can either adjust everything manually, or I can connect it to Wi-Fi and make all the settings on Tunze Hub. The pump runs on low voltage, so we have a power supply. This is an additional advantage in that we only have, in this case, 12 volts going in the water. So should this cable, which is an extremely well-made, durable cable, ever fail, we would have only 12 volts in the water. If this cable were to be damaged by, say, a fish or a sea urchin gnawing through it, we would have, in this case, 230 volts in the water. So DC is definitely safer. Personally, I'm not a huge general proponent of DC pumps, but for flow pumps, I would probably only go DC pumps. Even if I was a beginner, this is where I would invest my money. I wouldn't buy silly things like, in my opinion, a DC return pump or a DC skimmer, because these are readily available as AC products. I need my filter to be absolutely reliable. Whether it uses a couple watts more doesn't matter to me. What I want is reliability. But when it comes to flow, the ability to program all these patterns, to program waves, to turn my pump up or down, stop it when I want to change something, makes DC much more worthwhile. So if it was a reef tank, I would always spend the money on a DC pump. But you can do it with AC pumps, and there are applications where that's more suitable, even if you just wanted to add a spot of flow to something. The other thing, in these cases, with these DC pumps, because they always cost more money, you want to look at the warranty they give you. It's the same as I feel about cars. If I'm looking at a car and a manufacturer only gives me a 3-year warranty, I think, well, they don't even believe in it themselves. And so if I see a pump manufacturer is giving me 90 days in some cases, or 1 year, 2 years, it's not a big convincing reason to spend a few $100s with them. So look at the warranty. Tunze is 5-year warranty, and we've been around 60 plus years. So it's not like we'll be gone tomorrow. So do circulation pumps require frequent cleaning or a lot of maintenance? So you do need to maintain them. It's part of owning any pump, return pump, whatever. It has to be cleaned and serviced if you want it to last. So in this case, let's take this 6040. I'd have to remove this flow deflector. And with the DC pumps that we produce now, this becomes a lot easier because I can disconnect everything electrical and just take this away to the sink. The drive unit comes out, and this is critical. If you just leave this in, you're really not cleaning anything, because this is our interface surfaces that get dirty. And what will tend to happen is calcium will build up on that shaft and in the hole in the middle of the drive unit. So once we have these apart, we only take, personally I use 50-50 white vinegar and water, soak the pieces for a few hours, check that there's no white calcium deposits remaining. Then you just reassemble it, reinstall it in the tank, and you're all set. You may need to brush things. You get some algae buildup here. One thing I've learned is that as far as algae goes, if you're having more algae than calcium problems, you can just buy 3% hydrogen peroxide at the supermarket, drop the parts inside. Hydrogen peroxide oxidizes the algae off pretty well. You may need to soak it for a prolonged time and give it a few scrubs, but that also works quite well. Usually with normal reef tank levels, so that's something else to keep in mind. Say we're talking about, we've got a KH of around 9, we've got calcium around 415, 420, and our magnesium's at about 1350 or so. We usually want to do this every 6 months. I have seen people that they dose the trace elements into the pump thinking that they're directing it around the aquarium, and it's true, you are helping mix it in, but that is very hard on the pump. You're putting it right in there, it precipitates out, and so then you may need to do it more often. And there are people that have a school of thought that if I keep my levels very high, my corals will grow faster. Depending on what you're doing with your levels, it could be 2 to 3 months in those cases. Magnesium being higher tends to prolong the maintenance interval. KH, pH, and calcium being higher tends to shorten the maintenance interval. They're more or less the same in terms of assembly and disassembly. One special one here is the Stream 3. So the Stream 3 is a very unique magnetic drive pump. In my opinion, a wonder pump. This is my personal favorite because it doesn't have any sort of shaft. It doesn't have any sort of direct connection between the rotor. And that's because it's a magnetic drive system. So you see that's strapped down with plastic, and the reason for that is that the rotor is suspended in a magnetic field. All these other pumps and pretty much every power head on the market, you have a shaft, you have a magnetic field that spins it on the shaft, and in this case, there's two opposite magnetic fields, and this is suspended inside of it. So it's basically captive in the magnetic field. These pumps I use on my aquarium because they need very little maintenance. Since there isn't any sort of surface for calcium to deposit on, you really don't have much of any buildup. Plus, we have a very high amount of water flow gets pulled through the bottom, so we have a lot of cooling going through there. So to me, that's a big advantage. I actually moved my home aquarium from my home to my office, and I set that aquarium up in 2019, moved it in 2025, and I'm embarrassed to say this, but it was the first time I cleaned those pumps, and they all still worked. So they were pretty rough. They were covered with tube worms on the intakes, and they definitely were better off for being cleaned. But this sort of pump can go a very long time. But you have these special maintenance considerations like how to remove the drive unit, reinstalling the bearing, and the bearing, it's easy, but it's a very unique system. So you have to drop this in here, jostle it around until it's in the right position, and then reseat the rotor. And since you're pushing past two opposed fields, you've got to give it a firm push. This pump's also very unique in that since you can't really aim it, they provide these different deflectors. You install this basic protective grid, and so this is yet another system. With this deflector, I would get a very broad, wide flow, and I would position the pump upright. With this one, I get more of a kind of a broad flow. It's not as flared out as this, and then I would position the pump horizontally. And then this one is my personal favorite. They call this the flow rectifier, but you can imagine the flow is coming off a propeller spinning one way, and then we basically unscrew the flow and make it into a direct laminar flow, diffuse it, and we get a very direct, almost a jet. I like that flow because with this style of pump, we're aiming the flow along the glass and getting it around the tank, and it makes it very effective. So hopefully we answered some of your questions about how to choose a power head. We definitely would appreciate you considering our brand, but there's a lot of brands out there. I think we are the best, but I understand people have their own considerations as far as budget and other things. I'll always believe we build the best value, that you'll get the most for your money from us, but these same basic principles apply to any other brand on the market. Thank you.